Hello, everyone, and good day. Today, we're going to be talking about ways of expressing concentration. There are actually different ways of expressing concentration, but we're going to focus on solving problem involving molarity. So, in our problem, a solution whose volume of 375 ml contains 42.5 grams of sodium chloride. What is its molarity? So we know that molarity, or the equation for molarity, is equals to moles of solute over or divided by liters of solution. Since the given are in form of gram and milliliter, we're going to convert them into mole and liters. So mole for our solute and liter for our solution. So first, we're going to get the molar mass of our solute. So molar mass is equals to, we're going to look to our periodic table, 22.99 atomic mass. And then for the chlorine, we have 35.45. And we're going to add them, and it will give us 58.44 grams per mole, or we can just write them as 1 mole over 58.44 grams. So now that we have the molar mass, we're now going to convert our solute into mole. So 42.5 grams of sodium chloride times 1 mole over 58.44 grams, and that will give us, grams will be cancelled, so that will give us 0.727 mole of sodium chloride. So that is mole. And then now that we have our mole or our solute in form of mole, we're now going to convert our solution into liters. So 375 times 1 liter over 1000 milliliter. Oh, my bad. And that will give us 0.375 liters. So again, 0.375 liters. So now that we have our solute and solution, we're now going to solve for our molarity. And that will be molarity is equals to 0.27 mole, 0.727 mole over 0.375 liters. And we're going to get the result, and it's 1.94 molarity. So don't forget that it can be written or known as 1.94 mole per 1 liter. So either of the two answers are correct. So let us now move on. So now let us move on to our next topic, which is the colligative properties of solution. So there are actually different colligative properties of solution, but in this video we're going to focus on solving problems involving osmotic pressure. So with our problem, what is the osmotic pressure of 298 Kelvin of a 1 liter solution containing 37.3 grams of potassium chloride with molar mass of 74.6 grams per mole with gas constant 0.0821 liter atmosphere per mole. So we know that the equation of our osmotic pressure is pi, where pi represents our osmotic pressure here, is equals to molarity times gas constant times our temperature. So since gas constant and temperature are given, we're just going to solve first for our molarity. So since molar mass is already given, we're going to convert our 37.3 grams of potassium chloride into mole. So 37.3 grams of potassium chloride times our given molar mass 1 mole given molar mass 1 mole of potassium chloride over 74.6 grams per mole. So they're actually gram there. And then we have to multiply again 2 mole since we absolute, since we know that there is a K positive and Cl negative, and in every 1 mole of potassium chloride. So we're going to multiply that, and that will give us 1 mole. Now that we have the mole, and which is our solute, and the solution is already given, we're just going to substitute our given to our equation for molarity. So our molarity is equals to the solute, which is 1 mole divided by 1 liter, which is our solution, and that will give us 1 molarity. Now that we have the molarity, we can now solve for our osmotic pressure. We're just going to replace our equation or substitute the value of the given to our equation. So osmotic pressure is equals to 1 molarity times our gas constant 0.0821 liter atmosphere over Kelvin mole times 298 Kelvin, which is our temperature, and that will give us 24.5 atmosphere. Now we have our osmotic pressure. So now let us move on to our next topic, since we already got or learn how to solve osmotic pressure. So our next topic will be thermochemistry. So we're going to focus on solving problem involving calorimetry. So our problem is how much heat is required to heat 15 grams of water with a 4.184 joules per gram degrees Celsius from 20 degrees Celsius to 70 degrees Celsius. So we can solve that by our equation. Q is equals to mc delta T, where Q represents the heat absorbed or released. So our mass is 15 grams and our C is 4.184 joules per grams. By the way, C represents the specific heat capacity. So delta T is the final temperature minus initial temperature. So our final temperature here is 70 degrees Celsius and our initial is 20 degrees Celsius. So we're now going to solve this. We're going to multiply and this will give us 3,138 joules. And that is how much heat is required to heat 15 grams of water with a specific heat capacity of 4.184 joules per gram degrees Celsius from 20 degrees Celsius to 70 degrees Celsius. So thank you for watching.